Here I've sketched a wave with 4 cycles in a certain distance, another wave with 3 cycles in the same distance. What do we get if we combine these waves? What do we get if we superimpose them? Okay, the superposition tells us that, well, here our peaks are pretty close together, so that we're going to get a pretty good peak at this end. Okay, so we'll have probably a pretty good peak. Not sure just exactly how far to take it, but it's going to be somewhere between the length of this one and the length of this one. And actually, by the time we get out to this point, this one will have gone negative. Not sure I've really drawn it really well. Now, the peak, or the valley here, doesn't line up exactly with the valley here, but it does tend to kind of reinforce it. So what we're going to get is we're going to get a valley that isn't quite as deep as the peak is high. By the time we get over to this point, this wave is back to 0. This one is still negative. The two aren't equal and opposite until we get about here. So I'm going to say we're going to get a 0 point right about here. So we're going to come down here, not quite as far, and we're going to come up like so. Now, we could continue. The next place the two waves appear to be equal and opposite is probably about here. And for the most part, they're not reinforcing each other very well. We get this one is up, this one is down, then it's up, and then this one's down. And these aren't really accurately drawn, but what we're going to get is we're going to get something even a little less overwhelming than what we have here. And if we continue this, we see, well, I'm going to pause the video here so you don't have to watch me construct this. Okay, I've sketched a couple more points where the waves appear to be equal and opposite. As we move over toward this end, we see that the valley here tends to reinforce this valley. This peak doesn't exactly reinforce this peak, but from about this 0 on, this peak is higher than this one is low, and stays that way until we get over to this 0. So we're going to probably have something kind of like this, to where the two, I should have brought that back to 0, where the two pretty well reinforce themselves at this end. Now, what that does is it gives us, if these are sound waves, let's say, this wave will produce a nice steady sound, this wave might produce a nice steady sound, but when they're combined, we have a sound that gets quiet and loud within this distance. And the sound is loud here, quiet here, and gets loud here. This models the production of what we call beats. We have a beat wavelength that goes from here to here. Okay, every time this much wave passes us, we're going to hear the wave, the sound being somewhat louder, and then it'll go quiet, and then it'll get louder again, quiet. It'll go through the loud quiet cycle every time this distance passes by. From this we can see that we have one beat, one time interval within which sound goes from loud to quiet to loud. Every time the waves get one cycle out of phase. In other words, this cycle, there are only 3 cycles, there are 4 cycles here. So when this one gets one cycle ahead of this one, which occurs in this distance, we hear one beat. So we write that down. We have one beat every time one wave gains a cycle on the other, as we can illustrate with this picture. Now, let's say we have two waves of audible frequency, 100 hertz and a 97 hertz wave, and they're of similar amplitude, or they're fairly comparable amplitudes, and we hear those sounds combined. How many times will the 100 hertz frequency gain cycle on the 97 hertz frequency. Well, clearly that's going to happen 3 times a second because you have 3 extra cycles here in a second. So this is going to catch up with this and pass it 3 times every second. That means you're going to have 3 beats. So you get 3 beats per second out of this. The beat frequency, and this is a general general definition, beat frequency is the absolute value of F2 minus F1. We don't know which one of these F1, which one's F2. We just take the absolute value of the difference. That's how many beats we're going to hear per unit of time.